In this lesson, we will learn how to describe a graph. Just a heads up that we will be using notes for this. Please review the lesson on note-taking titled Note-Taking Suggestions for Distributions if you need a refresher. So let's look at your note sheet. As you can see here, on the back of the note sheet above pie chart is the area for describing graphs. Whenever you're asked to describe a graph, you always want to remember SOX-O. Now, what do I mean by SOX-O? Well, the first S stands for shape. We will always want to talk about the shape of a graph. O stands for outliers. C stands for the center of the graph. And S stands for how spread out the data is. And then there's this last O. Is there anything obvious about the graph that isn't covered in one of the other SOCs? Let's talk about each one of these individually. Our first S is shape. One common shape word that can be used to describe a graph is symmetric. A good example would be a box plot, where the median creates a mirror image on both sides. Or we could talk about skewed right or skewed left. Now, I always had trouble remembering which way is skewed right and skewed left. The direction that you are pulling the string is the direction that it is skewed. So if it is skewed this way, it is skewed right, or skewed to the higher numbers, as opposed to a graph that looks like this, which is skewed left, or towards the lower numbers. Sometimes you'll see graphs that have many gaps in them. Many times in dot plots, you'll see lots of spaces between the numbers. Be sure and address the gap by mentioning that it's there. If there's a gap in your data, like we see here at 5, you will also tend to see clusters of data as well. Where you have a cluster of data over here and a cluster of data over there, it's important to talk about those when you're describing your data. Sometimes you'll have bimodal data. Bimodal data is identified by two different peaks. A uniform graph has bars of equal height, or dots that go to the same level. You also could see a graph that we'll discuss extensively later on. It's mound shape, otherwise known as a normal curve. Whichever shape you describe, you must talk about the context of the question being asked. What is it asking? In an example from another lesson, we discussed students who live on campus or off campus and whether they participated in extracurricular activities. That is the context. You must include that context when you're writing. What you don't want to do is just say the graph is skewed right, period. I have no idea what the data is talking about, except that it's skewed right. So you need to make sure you always put context in a situation. Take example 1 here. Let's look at how to describe the shape of the graph in the context of the question. Looking at this graph, we see that it represents the length of songs and the frequency that it plays on iTunes. Looking at the shape of the graph, this is an example where it looks skewed to the right. If I were to trace over the top of this, can you imagine the string that is being pulled to the right? So we'll say this graph is skewed to the right, but I can't stop there. If I just say this graph is skewed to the right, my answer would be incomplete. We should say the distribution of length of iTunes songs are skewed right, or skewed to the higher values. Just by putting in the lengths of iTunes songs, I now have a complete answer. This is required for any tests you may take on this. The second letter in SOX is O for outliers. We define outlier as a data point that falls outside the normal pattern of data. Data sets may have none, may have one, or may have numerous outliers. Here are some examples of how you might see outliers in a graph. In a dot plot, most of the dots are in one area, but then on one side, you've got this little guy outside the normal pattern. We would call him an outlier. Or, in a box plot, they are distinguished by dots. As you can see in the box plot, you've got the regular box and whisker plot, which we'll talk about making later, and then you have the little dots. Those dots are outliers. The C in SOCS stands for center. There are a few choices for measures of center. Sometimes it's easy to just eyeball on a graph where the center of the data is. That's okay. If you want something a little bit more concrete, you can talk about the median or the mean. We'll go into more detail about finding the mean and the median of a set of data later in this section. Now let's look at example 2 and describe the center of the data in the context of the question. Example 2 is a type of dot plot, even though there are little X's rather than dots. It looks like it's representing the number of minutes studied. So to determine the center, I could just look at the graph and say, where does the center lie? It looks like the center of the graph is around 45 or 50 minutes. And it's okay to say that. It's okay to say the center of the number of minutes studied is between 45 and 50. Now, if you wanted to, you could actually count from the sides and actually find the middle X. That's another way to say that was the center. Now, I wouldn't want you to forget what we talked about with the O, the outliers. That little guy hanging out at 70 is outside the normal pattern. So we could say whoever studied for 70 minutes seems to be an outlier. The last letter S of SOCS stands for spread. Describing the spread means describing how the data varies. Data sets with small spread have data points that are very close together. Data sets with large spread have data points that are far apart. Here's an example of a graph with a small spread and one with a wide spread. Some choices for measures of spread are the range, looking at the difference between the minimum and the maximum numbers, the IQR, which stands for interquartile range, and the standard deviation. We will go into more detail about IQR and standard deviation in other lessons. Finally, the last letter O. If for some reason we miss something obvious about the graph that didn't get addressed in SOCS, then this is where we want to address it. For example, are there any gaps in the data? Or are there any clusters of data? This is just a time to stop and say, hey, did I fully describe the distribution? Let's test what you've learned so far with the check for understanding. Describe the graph using context. Pause the video if needed to write down your answer. Click play when you're ready to continue. Now here's the solution for this check for understanding. It looks like this graph represents scores on a final exam. Just looking at the graph can help you see what shape you'll need to describe. In the graph, the scores on the final exam are skewed left or towards the lower numbers. For the O, or outlier, if you said, well, there's a couple of people that scored between 0 and 20, that is true. But those people aren't way outside the normal pattern of data for this test. So I would say there aren't any outliers. The center is somewhere between 60 and 80, as you can see. Most of the people scored between 40 and 100, so that's talking about the spread. Now let's think about the last O, the obvious part. Is there anything obvious about the graph that's jumping out at you? If you do see something obvious, make sure that you mention it. Are there any noticeable peaks? Are there any gaps? Are there any clusters? Are there any extreme points that don't belong, etc.? In this case, the answer to all those questions is no. So you would not address that part. As we come to a close, here's a wrap-up. of what we covered. After this lesson, you should be able to do the following. Given a graph or distribution of data, describe the shape of the graph, determine if there are any outliers, find where the center of the graph is, calculate how spread everything is, and if there are any obvious features. In other words, make sure you address SOX-O. In addition, you should be able to write out a distribution in the context of the question. If I read your answer, I should be able to know what the question was about. That concludes the lesson on describing graphs. Remember, you can view this lesson as many times needed for better understanding. Thanks for watching.